Hey guys, it is Mrs. Rooker again, and I'm going to do day 4 with you, graphing inverse functions. So, graph the following function and its inverse. So, first one is in slope-intercept form. That's just a line. The slope, this is a throwback, it's been a little while. Slope is going to be 7. The y-intercept is going to be -4. We graph the y-intercept first, so graph -4. And then we do the slope, which is up 7 over 1. 1, 2, 3, 4, 5, 6, 7 over 1. Up 1, 2, 3, 4, 5, 6, 7 over 1. So nice, steep line. All right. Remember in the day 3 video I said to find the inverses, you switch x and y. That's how you do it on the graph as well. So I look at, for example, this point here. That was the point 0, -4. Well, I switch that. Instead of being 0, -4, it's going to become -4, 0. 1, 2, 3, 4. Then I look at the next point I had drawn. That was this point here. This was the point 1, 1, 2, 3. So 1, 3. I'm going to switch that. It's going to be 3, 1. 1, 2, 3, 1. Okay. And then my final point was way up here. This was 2, 10. I'm going to switch those. It's going to be 10, 2. 10, 2. So these lines down, or these points down here became my inverse function. You might notice we have these, well, I'm sure you noticed, these blue dotted lines down the middle of both of these grids. Those dotted lines represent the line y equals x. When you graph an inverse, you are just reflecting the function over the line y equals x. You see here, this point here was reflected over the line and ended up there. This point here was reflected over the line y equals x, this middle line, and it ended up there. Same with this point. Whoops, that point started here, reflected over there. So to graph an inverse function, you switch x and y. Or I guess and, you're reflecting, so I guess or, over y equals x. So that's what's happening here. All right, so the next one, this shape, it's a little throwback again. That right there is a quadratic. It's going to make a parabola shape. We find the vertex using HK. It's going to be opposite of -2 is 2. And then the number on the end is 0. So the vertex is going to be 2, 0. And then there's a negative in front, which means it's pointing downward. The pattern is over 1, down 1. Back to the start, over 2, down 4. Or I know some teachers do the 1, 3, 5. So you might remember it that way. All right, so that's the function. Now we're going to graph its inverse by switching all the x's and y's. So this point was the point 2, 0. I'm going to graph the point 0, 2. This point here is the point 1, -1. I'm going to graph -1, 1. This point over here is 3, -1. I'm going to graph -1, 3. Wait. This is 1, 2, 3, -1. I'm going to graph -1, 3. There we go. This point down here is 0, -4. I'm going to graph -4, 0. And then this point over here, this is my last point I graphed, was 4, -4. I think it was 4, -4. So I'm going to graph -4, 4. And what I have here looks like a sideways parabola. It was reflected over this line, y equals x. So you just switch the x's and the y's. All right, this is more recent. We did this last unit. Graphing the square root function, we're going to find the start point. It's going to be opposite of 6 is -6, same as the number on the end, so 0. -6, 0 is going to be right here. And then the pattern is going to be over 1, up 1. Back to the start, over 4, because that's our next perfect square. Up 2, because square root of 4 is 2. So 1, 2, 3, 4, up 2. Back to the start, our next perfect square is 9. So over 9, up 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. And then we might actually have room on this. Actually, yeah, we do have room. We're going to go back to the start. We're going to go over 16, because 16 is a perfect square, and up 4, because the square root of 16 is 4. Alright, so that's the function. Now we need to graph its inverse. This was the point -6, 0. I'm going to graph the point 0, -6. This was the point -5, 1. I'm going to graph 1, -5. This was -2, 2. I'm going to graph 2, -2. This one's interesting. This is the point 3, 3. If you switch 3, 3, it's still 3, 3. And then this last point was 10, 4. I'm going to graph 4, 10. Oops, I went a little squiggly on that. I didn't mean to. It should be a nicer curve than that. But yeah, it looks like it was reflected over that line, y equals x. And what we have here, you might notice, this looks like half of a parabola. See the other half? Be a parabola. Alright, next one, x to the 1/3 power plus 3. X to the 1/3 power, this was from last unit too. Remember this is, oops, this is cube root of x plus 3. So we find the start point opposite of whatever's being added in here, which is nothing, and then same as the number on the end. So 0, 3. And then we're going to go over 1, up 1. Back to the start, over 8, up 2, because the cube root of 8 is 2. And then I do the same thing in the opposite direction, but going downward this time. Over 1, down 1. Over 8, down 2. That gives us this elongated S shape. So that's the original function. To graph the inverse, we switch x and y. So let's start with this point over here to switch x and y. This was 8, 1, 2, 3, 4, 5. I'm going to do 5, 8. This point here is 1, 4. I'm going to do 4, 1. This point here is 0, 3. I'm going to do 3, 0. This point here is -1, 2. I'm going to do 2, -1. And then this point way over, oops, way over here is -8, 1. I'm going to do 1, -8. Alright. And then what we have there is a cube function. So the inverse of a cube root is a cube, which hopefully kind of makes a little sense. Alright, the domain and range of inverse functions are swapped. Because if you're swapping your x's and y's, well, domain is the set of all x values, and range is the set of all y values. So if the x's and y's are swapped, the domains and ranges are also swapped. So if the domain of one function was all real numbers, the range of its inverse will be all real numbers, and vice versa. Alright, graph the following and its inverses, and then state the domain and range. So we're really just doing more of the same. I'm going to go a little faster because we've got several left to do. Alright, we're doing more of the same, except now we're including domain and range. So, this is a square root function. To find the start point, it's going to be -3, -4. And then it's got a negative in front, so instead of going over and up, it's going to go over and down. over 1, down 1, back to the start, over 1, 2, 3, 4, down 2, because the square root of 4 is 2. And I could do 9 also, because 9 is a perfect square. 1, 2, 3, 4, 5, 6, 7, 8, 9, down 3. So there's the function. And then the inverse is going to be, instead of -3, -4, it's going to be -4, -3. And then instead of, this is the point -2, -5, it's going to be -5, -2. And then instead of 1, -6, it's going to be -6, 1. And then my last point that I drew was 6. -1, 2, 3, 4, 5, 6, 7. 6, -7, so it's going to be -7, 6. Oops. Again, sorry, not very straight lines. Alright, it's not super clear on here whether it's asking for the domain and range of the original function or the inverse, but I'm going to go with that it's asking for the domain and range of the inverse. Alright, so domain is how far left and right something goes. It goes forever to the left. That's what this arrow means. It's going to keep going to the left. So that's going to be -infinity. And then how far right does it go? Well, we said that this was the point -4, -3. So the furthest right point is going to be -4. We put a bracket because that point is included. All right, range. How high up and down does it go? Well, we always start with the lowest. The lowest point on there is -3. And then there is no highest point. The arrow means it continues on to infinity. Alright, next one we got over here is also a square root function. If you want, you can rewrite this square root instead of 0.5 power. Alright, so the start point is going to be opposite of what's being added to the x. There's nothing in there, so that's 0. And then same as the number on the end, 0, 6. And then the 2 in front affects the amount we go up. So instead of going over 1 up 1, I'm going to go over 1 up 2. Back to the start, instead of over 4 up 2, I'm going to go over 4. 1, 2, 3, 4, up 4, because I'm going up twice as much. So that's the function. The inverse is going to be a reflection over the line y equals x. And I'm switching the x's and y's. So if this is 0, 6, I'm going to have 6, 0 on mine, on the inverse. The next point was the point 1, 8. I'm going to have the point 8, 1. The final point was the point, I think it looks like 4, 10. It's going to be 10, 4. Alright, and then domain. How far left and right does it go? It has a furthest left point. This is the point 6, 0. Bracket, because it does exist at that point. It is included. It doesn't have a furthest right point, so we put infinity. And then range, how far up and down does it go? It has a lowest point. The lowest point is 0. Put a bracket because it is included. And then it doesn't have a highest point. It continues up and up forever. So infinity. Alright. Number 7. Without graphing, find the domain and range of the function and its inverse. So, I know it says not to graph, but I'm going to do a quick little sketch. We know this looks like this, right? And it's got a start point of -2, 0. That helps me to visualize so I can figure out the domain and range more easily. So the domain of this function is going to be -2 to infinity. Oops. And then the range of this function is going to be 0 to infinity. Which means the inverse. The domain is going to be 0 to infinity. And the range is going to be -2 to infinity, because they're swapped. All right, almost done, just a couple more problems, and we're going to talk about functions. A vertical line test is if you can draw a vertical line anywhere on the function and it crosses the graph more than once, it is not a function. We'll talk about that more in just a second. Horizontal line test. Horizontal line test is kind of the same. I'm actually not even going to write this whole thing out because I don't love this test. The horizontal line test says that if you draw a horizontal line on a function and it crosses the graph more than once, then its inverse is not going to be a function. We'll talk about that more when we actually look at the graphs, but I'm not going to write it down because one, I don't want to waste your time, and two, I kind of prefer using a little bit slightly different method, but anyway, we'll move on and use this. So is the graph of x squared minus 2 a function? Is the inverse a function? So x squared minus 2. So that's a parabola. There's nothing being added in there with the squared, so that's going to be 0, and then -2 on the end. So the vertex is 0, -2. And then the shape of a parabola, or the pattern, is over 1, up 1, back to the start, over 2, up 4. Or if you have some teachers that do the 1, 3, 5 rule. So over 3, up 1. I'm just going to do kind of a rough sketch. It doesn't really care that it's not a perfect graph. All right, so to determine if this is a function, I draw vertical lines, or I imagine if I were to draw a vertical line, would that vertical line cross the graph more than once? Well, here it only crosses once. Is there anywhere on this graph that I can draw a straight up and down vertical line and have it cross more than once? The answer is no, which means this is a function. And then it also asks, is the inverse a function? Well, let's picture what the inverse would look like. The inverse would be reflected over the line y equals x. It's going to be sideways. Now this isn't a good sketch of what it's going to look like, but it would be reflected over the line y equals x. So it's going to be turned sideways. If it's reflected sideways, then if you were to draw a vertical line through it, it would cross more than once. If it's a sideways parabola, your vertical line is going to cross more than once. So the inverse is not a function. So the horizontal line test is saying, okay, since a horizontal line crosses more than once, the inverse is not a function. All right, so to recap, this was a function. The inverse, which would be flipped on its side, is not a function. All right, is the function of square root of 2x a function? So I'm not going to graph the entire thing, but I'm just going to do kind of a sketch, a really rough sketch. The start point is going to be 0, 0, and it's a square root function, so it's going to be like this. This isn't a super accurate sketch, but that's okay. There is nowhere on here that I could draw a vertical line and have one vertical line cross more than once. So yes, this is a function. Picture the inverse. An inverse would be a reflection of that. It'd be kind of flipped on its side. It would probably look something like that. Again, there's no way that I could draw a vertical line and have it cross more than once. I didn't do the greatest sketch. This shouldn't curve totally up. I'm sorry. It would continue kind of like this, and it would pass the vertical line test. So the inverse is also a function. So yeah, back to that horizontal line test. If you were to draw a horizontal line on this, it wouldn't cross more than once, so that's how we know the inverse is a function. All right, that is it. I am done with this video. All right, have a great day, guys. Thanks for listening.